Okay, videoing and streaming. So let's go 3, 2, 1. Okay, so I've been meaning to make this video for about a week, and it's all about the meteorite, the evidence that they found of a meteorite that hit Greenland. One thing that I needed for this was kilo annum, which is 1,000 or 10 to the 3 years. First, I'd like to talk about Younger Dryas. It becomes relevant later on. So let's have a look at this. Evidence for an extraterrestrial impact 12,900 years ago that contributed to the megafaunal extinctions and the Younger Dryas cooling. So let's have a look at what the Younger Dryas cooling actually looks like. Here it is, it's a GIF. Oh, excellent. Right, along the bottom we've got thousands of years before the present. So we've got the present day, and then we've got 5,000 years ago, 10,000 years ago. The blue line is snow accumulation and the red line is temperature. So over the last 10,000 years or so, we've had, let's say, you can see a variance in the temperature, but there isn't a strong trend. Then between 10 and 15,000 years ago, we have this very deep dip that lasts, I think, about 1,300 years. That's the Younger Dryas. Okay. A carbon-rich black layer dating to about 12,900 years ago has been previously identified at approximately 50 Clovis age sites across North America and appears contemporaneous with the abrupt onset of Younger Dryas cooling, which we'll call YD for the rest of this. The in-situ bones of extinct Pleistocene megafauna along with Clovis tool assemblages occur below this black layer but not within or above it. Causes for the extinctions, cooling and termination of the Clovis culture have long been controversial. In this paper, we provide evidence for an extraterrestrial impact event at 12,900 years ago, which we hypothesize caused abrupt environmental changes that contributed to cooling, major ecological reorganization, broad-scale extinctions, and rapid human behavioral shifts at the end of the Clovis period. Now, this paper was published in October 2007. Okay, so Younger Dryas, there was something here. Consideration of many other very important factors that should be considered, as well as the black mats and nano diamonds. Abstract. The genesis of the Younger Dryas stadial cold interval remains an enigma. The onset was both climatologically unexpected and extremely sudden. The two principal theories are diametrically opposed, and the proponents of both deeply committed. The debate to date has been primarily centered on some unusual black mat deposits that may or may not be linked to a cosmic origin. What has been lacking in the wider discussion are all the other important features associated with the Younger Dryas. The following addresses many of these in the hopes of their inclusion in future debate. So let's have a little look. The Younger Dryas onset remains little understood event. The cause of the 1,300-year-long interval continues to be debated. There are two completely different theories that have split the scientific community. One group strongly endorses an overall slowing or complete stoppage of the Northern Atlantic Ocean circulation 13,000 years ago. The other camp maintains that a catastrophic event originating from the cosmos was the cause. Okay, so why am I talking about this? Well, actually, before we get onto it, they keep talking about Pleistocene. When was the Pleistocene? Okay, 2.58 million years ago. The Pleistocene is the geological epoch which lasted from about 2.6 million to 11,700 years ago. Wow. Wow. The end of the Pleistocene corresponds with the end of the last glacial period and also with the end of the Paleolithic age used in archaeology. Right, so here we have Greenland, And for example, here's England over here, here's Great Britain, United States, and here is the Hiawatha Glacier. And see this semicircular thing, which is sort of over to the western side of the glacier, and this bit that sticks out here will all be relevant, but I've definitely read that this circular protuberance is actually part of the of what they now believe is a cosmic impact crater. So they're saying that a meteorite hit Greenland, and it was an iron meteorite, and it was about a kilometre and a half wide, I think. So let's continue. Raman spectroscopy comes up, and so let's just read it. Raman spectroscopy, named after Indian physicist Sir C.V. Raman, is a spectroscopic technique used to observe vibrational, rotational and other low-frequency modes in a system. Raman spectroscopy is commonly used in chemistry to provide a structural fingerprint by which molecules can be identified. Okay. I've got the PDF itself is here. Geology. So this is in the Science Advances research article, a large impact crater beneath Hiawatha Glacier in northwest Greenland. We report the discovery of a large impact crater beneath Hiawatha Glacier in northwest Greenland. From airborne radar surveys, we identify a 31 kilometre wide circular bedrock depression beneath up to a kilometre of ice. Okay, and then they go into loads of detail. The age of this impact crater is presently unknown, but from our geological and geophysical evidence we conclude that it is unlikely to predate the Pleistocene inception of the Greenland ice sheet. Okay, but as we saw, if that puts it in a range of 2.6 million to 11,700 years ago. So one thing I definitely wanted to say in this video, I will put some links below to a couple of guests that have been on the Joe Rogan podcast, and they're some of the most popular podcasts that Joe Rogan does, and it's Graham Hancock and Randall Carlson, and they have some really fascinating photographs. They've been to some places up in the north of America. They've been up to the north of America somewhere, and they've seen some astounding things that seem to indicate massive water flows, and it's really amazing to see them discussing that. So I'll put links below. The scientific exploration of Greenland has extended for centuries because of its remote location and ice cover. Exploration of features beneath the ice is a relatively new development, owing to the mid-20th century advent of borehole drilling through ice and radar sounding. While airborne radar sounding of the Greenland ice sheet began in the 1970s, increasingly comprehensive surveying of the ice sheet has only become possible over the past 2 decades. Beginning in the mid-1990s, extensive airborne radar sounding has revealed a hitherto hidden landscape beneath the Greenland ice sheet. Here we describe a new landscape feature in remote northwest Greenland, initially identified through incidental airborne radar sounding and subsequently studied through additional airborne and ground-based field studies of the ice sheet and deglaciated foreland. So what I love about this is we're actually talking about the discovery of a massive impact crater that could be 12,000 years old. We could be looking at the smoking gun for some incredible cosmic event that would have absolutely changed the history of humankind. And Graham Hancock sometimes describes the human race as just having this very short memory. It's as if something really awful. We know that the Younger Dryas happened, we just don't know what caused it. It became really, really cold, and that must have affected humans in a massive way. Using data collected between 1997 and 2014 by NASA's Programme for Arctic Regional Climate Assessment and Operation Icebridge, in combination with 600 kilometres of new airborne radar data collected in May 2016, we identified a large circular depression in the bed topography of the Greenland ice sheet. This structure is covered by up to 930 metres of ice, but has a clear circular surface expression. An elevated rim encloses the relatively flat depression with a diameter of 31 kilometers and a rim to floor depth of 320 meters. In the center of the structure, the bed is raised up to 50 meters above the surrounding topography. The overall structure has a depth to diameter ratio of 0.01 and is slightly asymmetric, with a gentler slope toward the southwest and maximum depth in the southeast of the structure. Two winding subglacial channels up to about 500 meters and about 5 kilometers wide intersect the southeast flank of the circular structure. Before entering the structure, the northern channel merges with the southern channel and then spills over a large breach in the structure's rim upon entering the main depression. These channels do not have a recognizable topographic expression within the structure. On the downstream side of the structure, there is a second smaller breach in the northwestern portion. Ice flows through this second breach to form the tongue-shaped terminus of the Hiawatha Glacier. The present ice sheet margin lies about 1 kilometer past this northwestern rim, and it is the circular depression itself that contains the semicircular ice lobe that extends conspicuously beyond the straighter ice sheet margin farther southwest. So let's just go and have another quick look at that. So what are we saying? On Google Earth, we have this semicircular, what are they calling it? Semicircular ice lobe. Semicircular ice lobe that extends conspicuously. There it is. What I wanted to do actually is go back to the document, because it's actually really important. In the introduction, that's it. Glaciofluvial sediment from the largest river draining the crater contains shocked quartz and other impact-related grains. Geochemical analysis of this sediment indicates that the impactor was a fractionated iron asteroid, which must have been more than 1 kilometer wide to produce the identified crater. There we go. So, just to recap, they found a crater. Part of the crater is actually very clearly conspicuous already. But as I read in another article, there are lots of circular objects on the Earth that aren't impact craters, but the shocked quartz and other impact-related grains that are flowing out of the crater indicate that yes, this was a meteorite. So and also that it was iron, and that it was big. So we've got a 31 kilometer wide crater and probably 1 kilometer wide, possibly 1.5 kilometers, I think I read, iron asteroid. And the only unknown at the moment is the date, the exact date. That's the big story, really. I wanted to talk about Younger Dryas first. Okay, what next? That's it. Okay, so I'm still learning about this, but I just really wanted to share it. I think it's fascinating. There will be lots of links below the video. Okay, so, for me, this kind of thing, this is exactly the kind of video that I want to make. I just think it's really exciting, sort of imagining this amazing history of the Earth. And it's also, it's slightly frightening when you know that there was the Tunguska event that wasn't so long ago, and I definitely want to make a video about that. My battery's going flat. If you've enjoyed this video, please subscribe, please like, and click the bell. Thanks a lot.